Hey guys, these are notes for 3.6. They're called dilations or resizing. And when you resize a shape, it gets bigger or smaller. That means this is the one that's not isometric. It's not a rigid motion because it does not stay the same size. One gets bigger and smaller, but they still look similar. They still look the same. All the angles stay the same. Relative sizes are the same. For example, the face and the body are still in proportion. So, I mean, the face is still proportional to the body, but the size of everything just doubled or tripled or whatever. We could also call these enlargements or reductions. Enlargements or reductions. All right, let's look at an example of a dilation on the Math is Fun website. So if you can go to this website, that would be beneficial. You could take a look at it. And it takes a second to come up. Here it is right here. We're going to put a 2 in here. We're going to double the size. So that's what the 2 means, making it twice as big. Let's see, what do I want to put in here? We want to put 50 in each of these. Okay, so we'll see it a little bit better if we put 50s. So 50 and 50. This is what you want to put in yours. And we want to hit the red triangle. And we're going to hit resize. And here's the 50-50 point. And you can see that this length right here is the same as this length. What that means is that this length to this one is half the length to the big one. The new one is double that because we resized it twice. So instead of going to the point once, we're going to go 1, 2 to get to the new point, because we're going 2 times. So that's called resizing. Now you could also resize around the origin. I could put zeros in these. And we could, triple it. Or put a 3 there. Resize it. This time it's going to be coming out of the origin. And it's going to be 3 times as big. So 1, 2, 3 times as big as this 1 right here. So that's called resizing. Now if you notice, the shape does not change. The shape is the exact same shape. It just got way bigger. That means these angles stay the same. This angle is the same as this angle. They just made a much bigger size. And I can resize anything I want on here. I could take this triangle right here, and I could simply resize it by pulling this thing right here, and it's staying the same. It's just getting bigger and smaller. Okay, now if I was to move this one, now the angles are changing. I'm stretching. The angles are changing. That's way different. That's not a resize. That's a stretch. So resize is where all the angles stay the same, and the figures are actually called similar figures. So you can plug that in, draw that on there. Let's move to the next slide. Let's do some practice. Draw an image after a dilation scale factor of a half. Ooh, half. That means half the size of this picture right here. So we want to take this shape and draw it half the size from the origin point. Here's what it will look like that you should draw on your paper. Is that we're going to put a dot halfway to the origin because we're going to cut this in half. So D, the new D prime comes right there. So let's label that as D prime. And C is here, so this would be C prime. E is down here, so this would be E prime. Oops, not D prime, E prime. So a resize that's less than 1, half, and like in this case is a half, less than 1 is going to make things smaller. Greater than 1 is going to make things bigger. 1 by itself would just keep it the same size, and that would be a rigid motion. So let's put our points in here. So D prime becomes 3, 5. 3, 5. That's D prime. What do you notice about those? 6 and 10, 3 and 5. Looks to me like 6 got cut in half and 10 got cut in half. And what was my scale factor? A half. So that means we cut everything in half. So if that makes sense, then this point right here is going to be 3, -1. And if we put that in there, let's test it and see, is C prime 3, negative 1. Boom, there it is, C prime. And we cut that in half 2, cut that in half negative 3. So I'm thinking 2, negative 3 would be E prime. 2, negative 3, E prime. Boom. So the rule there was to take the both X and the Y and cut them in half. So a dilation rule is just based on its scale factor. Let's take this one. That's when you're going through the origin. The main thing when you're going through the origin. So here is a rectangle, T, U, V, W. Dilation scale factor of 5, centered at the origin. Okay, the scale factor is 5, so we want to make it 5 times larger than this one. So if this is over 2, I want to do 5 times that. It's going to be over 10. So it's going to look like that. So instead of just 2 here, it's going to go all the way over to 10. And this one was just like down 1 and over 2. It's going to be down 5 and over 10. So everything got scale factored by 5. So that means we're going to multiply everything by 5 here. So negative 2 times 5 is going to give us negative 10. And negative 1 times 5 is going to give us negative 5. I'm betting that T prime is negative 10, negative 5. Let's see, negative 10 and negative 5. Boom, T prime, there it is. This was T, this was T prime. U prime is going to be 5 or 10, negative 5. So 10, let's make this smaller. 10, negative 5. It's going to be U prime. Okay, if we tried that, it'd be over 10. Down 5, there's U prime, good. And we're looking at 10, 0 for V prime. 10, 0. So over 10 and up 0 is V prime, yep. And then negative 10, 0 is your last one. Negative 10, 0 would go right in there. So what's the rule? Well, the rule is to take your X and multiply it by 5, and to take your Y and multiply it by 5. And that would be your rule. 5 times the X and 5 times the Y if it's a scale factor of 5. Alright, let's try this one. It says write the coordinates of the vertices after a dilation with scale factor 4. Okay, so that means that's a pretty easy rule to write. If the scale factor is 4 and we're going through the origin, it's just going to be 4 times X and 4 times Y. So that means that this point right here is going to be negative 8, negative 8. Okay, and then this point right here is going to be negative 8, 0. And this one's going to be 8, 0. And then this one is going to be 8, negative 8. And if we test that, oops, let's draw some points in here. So let's test our theory of just since it's a dilation of 4, of taking everything multiplying by 4. So negative 8, negative 8. Negative 8 would be right there. Negative 8, 0 would be right there. Or positive 8, 0 would be right there. And 8, negative 8 would be right there. If we drew in that rectangle, would that be a dilation of 4? Well, let's test it. This has a 2 right here, so instead of 2, we're going to do that 4 times. So 1, 2, 3, 4 times. Yep, there it was. This is 2 here, so 1, 2, 3, 4. Yep, that is it right there. So your rule was 4x and 4y. This one is going to have a scale factor of 5. So again, that's another nice and easy one for us. It's going to be 5 times x. And that's going to be 5 times y. So let's see, our new points would be negative 10, negative 10. That would be our first point. Negative 10, 10 would be our second point. Negative 10, 10. And let's see, 5, negative 10 would be the last one. Because negative 1 times 5 would be 5. Negative 10 would be our last points. 5, negative 10. Alright, so let's make those dots and see what that looks like. If it looks like a real dilation with a scale factor of 5. Negative 10. Negative 10, negative 10. Way down here. Negative 10. Positive 10 would be way up here. Wow, that was a big one. And 5, negative 10. So 5, negative 10 would be way down there. Let's connect those and see what it looks like. Sure enough, U would be 5 times as long from the origin to each one. From here to here, you go over 1 and down 2. Here you'd go over 5 and down 10. So you multiply both of them by 5. So that is correct. That is a dilation 5 times as big as this one. All your points are 5 times as large. Okay, the green shape is a dilation of the black shape. So the green shape's the dilation. That means it got smaller. That means our scale factor should be less than 1. And it looks like we're from the origin, we're going to go up 1, 2, 3, 4 over 1, 2, 3, 4, 5. Well, actually, let's just take points. I think with points we can do it better. So that's going to be 10, 8. That's going to be the point 10, 8. If we want to find the scale factor, that's 10, 8, and this is 5, 4. And to find the scale factor, you simply put x over the x, 10 divided by 5, and 8 divided by 4. And if they both come out the same answer, you know you got a scale factor. So you divide those two, and your scale factor, wait, the green one's the scale factor, my bad. So that means that it's going to be the opposite way around. It's going to be the 5 on top of the 10. And it's going to be the 8, the 4 on top of the 8. Because the scale factor, the green one, is the smaller one. So that means you have to have a scale factor less than 1. So if I had 10 over 5, that would be a scale factor of 2, which wouldn't make sense because it's getting smaller. It's not twice as big, it's actually half the size. So our scale factor would be 1/2. Actually, let's just do it this way. 1/2 would be our scale factor. And then the blue shape is a dilation of the black shape. So this time the blue shape is getting bigger. And it says, is it an enlargement or a reduction? Well, it's getting bigger, so the blue shape definitely got bigger. It has to be an enlargement. So enlargement would be that one. That would be your answer right there. All right, there you go. That would actually have a scale factor of 2 up to 10 would be a scale factor of 5 because 2 times 5 is 10. So that would be an enlargement with a scale factor of 5. It would be 5 times as big as the small one. All right, see you guys later.